All right, on to our next video, and this talks about acid and base solutions using the pH scale. All right, so we did talk about what pH meant at the beginning of in the first video, the intro video. So pH means power of hydrogen or parts hydrogen. All right, so you're measuring how much hydrogen is present. All right, and remember it's on a scale from 0 to 14. The 0 to 6.9 is your acid, 7 is neutral, 7.1 to 14 is your base. All right, now the interesting thing about this is that pH is actually based off some math numbers, okay? And the math numbers we're talking about are logs, okay? So logs and anti-logs, which you should have on your calculator, which will be useful. All right, so you can actually calculate these things by knowing one or the other. So, know where your log button is, how to use it, know where your anti-log button is, and we'll see what we can do with this stuff in a second. All right, so, and then the pH scale. So, this part, what is the pH scale, and what do we got? Well, we know from 0 to, let's just write the whole thing out. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh, I'm going around the room, 12, 13, 14. Did I say it all? No. Kind of, maybe. Well, you're right, you know there's a 14 down here. All right, so let's start with 0. So we know these, usually from this range to this range is going to be your strong acids. Okay, somewhere in there. There's a little bit of gray area. And then anywhere from like 4, usually about 5 to 6-ish, this is going to be where your weak acids are. Exactly 7 is neutral. Only exactly 7. All right? Then your weak bases, and then anywhere from like usually around 12-ish, this is where your strong bases are going to be. All right, so let's identify a couple things here. Your blood, I believe, is slightly basic, I believe. Very, very, very low, but slightly basic. It's kind of close to neutral. Milk, I believe, is slightly acidic, a very, very weak acid, but nonetheless very close to neutral. Vinegar and those things are like down in this range. Okay, vinegar, battery acid is way down here, so it can actually hurt you pretty bad. Household cleaners like lye, stuff like that, they're going to be up here. Some weak ones are going to talk like antacids are going to be in this range, stuff like that. Vinegar is we already talked about, and those kind of deals. So we're going to run into, hopefully get the scale kind of going, but the interesting thing about this scale is that for every power, for every one you jump on the pH scale, it's actually a log. And what do I mean by log? Well, 1 is actually 10 to the negative 1 power. And this would be 10 to the negative 2, 10 to the negative 3, in concentration, in logs I'm talking about here. 10 to the negative 4, 10 to the negative 5, okay? And so on and so forth. So these numbers actually coincide with logs and concentrations, all right? Oops, it's 6, 10 to the negative 7, all the way up to 14, all right? So those numbers here will come in handy when we start dealing with calculations down here. But realize the pH scale is kind of the standard. Most people use it. Know where your strong acids, strong bases, where your weak acids, weak bases. What makes it weak? What makes it strong? A strong acid will, when you put it in water, completely dissociates, whereas a weak acid will only slightly dissociate. In other words, it'll bounce back and forth. We'll get more into that later. All right, so I hope this video helped. We'll talk to you later.